So welcome back. In this video, I'm going to be going over AMC 10B 2021 spring 1 through 5. So I'm going to be going through the AMC 10B spring. I'm also going to try to keep doing some AMC 12 problems, but sometimes they take me a little while to work through. So, okay, number one, how many integer values of x satisfy absolute value of x less than 3 pi? Well, 3 pi, so pi is 3.14 ... So 3 times pi, right? 3 times pi, which is 3 times 3.1415 ... right? Is obviously greater than 9, but it's also less than 10, right? Because in order for the value to end up being larger than 10, the decimal portion would have to be greater than 0.33333, which it's not. So therefore, we know 3 pi is in between 9 and 10. So when finding absolute value of x less than 3 pi, we're really saying, we can essentially say it's absolute value of x is less than 10, right? We can think of it like that. Because remember, we're only considering integer values of x. So since 3 pi is less than 10, then, right, it'll work. So another way you can think about this is to say negative 10 is less than x is less than 10, right? And then we just have to figure out how many integers that's going to be. Well, if you think about it, it's going to be negative 9, 8, 7, 6, 5, 4, 3, 2, 1, which is 9 numbers, right? But then you're also going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's another 9 numbers plus 0. So you have 9 plus 1 plus 9, which is 19. So there are 19 integer values that satisfy this equation. So pretty easy start, nothing too crazy. Okay. Number 2, what is the value of square root 3 minus 2 square root 3 squared plus square root 3 plus 2 square root 3 squared? Okay. Well, luckily, when we square root a square, we end up with the absolute value of that term, of whatever that expression is. So like in general, like square root of square root of, oh, sorry, didn't mean to do that. Square root of a squared will always equal the absolute value of a. So that can make this a lot easier. So first thing we need to know is 3 minus square root 3, is that positive or negative? Square root of 3 is that more or less than 1.5? Square root of 3 is 1.7, right? Square root of 3 is a little bit greater than, yeah, it's like 1.73. I mean, I knew it was 1.7. I just wanted to check on the calculator for more, but I know you can't use a calculator, but so you should know that square root of 3 is approximately 1.7, which means that this is negative, right? 3 minus 2 root 3 is negative, right? Because this is larger than 1.5. So when we take the absolute value, it's going to be the negative of that. So it's actually going to become 2 square root 3 minus 3. But 3 plus 2 root 3 is obviously positive, so that's just going to stay the same. So now when we add these together, what do we end up with? Well, minus 3 and positive 3 cancel out. 2 root 3 plus 2 root 3 is 4 root 3. So the answer is D, 4 root 3. So just a little trick of knowing square root squared is the absolute value, right? Number 3, in an after-school program for juniors and seniors, there's the debate team with an equal number of students from each class on the team. Among the 28 students in the program, 25% of the juniors and 10% of the seniors are on the debate team? How many juniors are in the program? Okay. Um, equal number of students, each class in team. 28 students, so that means 14 and 14, right? So we have 14 juniors and 14 seniors. 25%. Oh, I see. So it's not saying there's 28 students, but they're not all in the program. There's an equal number of juniors and seniors. Um, I see. Okay. So we have 28 students total, 25, but some of them are juniors. So there's juniors plus seniors equaling 28, right? And we know 25% of the juniors is equal to 10% of the seniors, right? Yeah. Because I was confused because I was saying on the debate. So there's an equal number of juniors and seniors on the team. So how could we solve this? Well, we could do a substitution, right? So we can say S equals 0.25 divided by 0.1j, but dividing by 0.1 is really multiplying by 10. So S is 2.5j, right? So then we can substitute that into the equation and say j plus 2.5j is 28. So 3.5 j is 28. We know 7 goes into 28 4 times. So 3.5 goes into 28 8 times. So j is 8, right? We have 8 juniors, right? Which means we have 8 seniors. Oh, no, sorry. So we have 8 juniors total, which means we have 20 seniors total. Okay. So okay. So there's 2 juniors and 2 seniors on the debate team, but it's asking how many juniors are in the program. So that's just the total number of juniors, which is 8. Okay, that question's a little tricky because there's a lot of like switching between program and debate team. Like there's a debate team, equal number of students, and there's 28 students in the program. How many, right? 25% and 10% are in the debate team. How many juniors are in the program? So like switches back and forth between team and program. So okay, I mean but that just shows how you have to be very careful when reading the question, right? At a math contest, 57 students are wearing blue shirts and another 75 students are wearing yellow shirts. The 132 students, is that the, yeah, okay, are assigned into 66 pairs, and exactly 23 of these pairs, both students are wearing blue shirts. And how many pairs are both students wearing yellow shirts? Well, 23 pairs is 46 students, right? So we have 46 students out of the 57 who are wearing blue. So that means we have 11 more blue shirts left over, and we have 75 yellow shirts left over. Right. Oh, exactly 23. So that means we cannot have any more pairs with both wearing blue. So that means these 11 pairs, these 11 blues each have to pair with a yellow. So then we have to do 75 minus 11, which is 64. So 64 yellow 64 students wearing yellow shirts are going to get paired together. So that means that you're going to have 32 pairs of students wearing both yellow shirts. So again, just a little tricky with the wording, right? Just be careful. The key thing with these early problems is they're pretty easy, but you don't want to make any careless errors, right? That's always the most important part. Number 5, let's see. The ages of Johnny's 4 cousins are distinct single-digit positive integers. 2 of the cousins' ages multiplied together gives 24. Well, if 2 single-digit integers multiply together to equal 24, that gives you 2 possibilities. That's either 3 and 8 or 4 and 6, right? The other two of the ages of Johnny's 4 cousins, the other 2 multiply to 30. So to multiply to 30, 2 and 15, 3 and 10, 5 and 6. So they have to be 5 and 6. Now, so if that's 5 and 6, that means the other pair has to be 3 and 8 because it says distinct single positive integers. So what is the sum of their ages? 3 plus 8 plus 5 plus 6. 3 plus 8 is 11, 5 plus 6 is 11, 11 plus 11 is 22. Okay. All right, so that's 1 through 5, pretty easy. All right, in my next video, I'll do 6 through 10. All right, and I hope to see you in my next video.